Welcome again to this series about Python programming. My name is Julio Castillo, and as I told you the last session, we will learn how to program using Python, but through this official tutorial. Okay, so that's the goal. And the idea is to take this tutorial from python.org. I will give you this link in the description, sorry, in the chat. And the last session we see some generalities about Python. But now today it will be our first lesson trying to understand how to use Python to process some data. Okay, very basic data, but it's the fundamentals of this subject. Okay, so please go to docs python.org. You can find tutorial for the version 3. Also, I think that the last version of Python is 3.12, but we will be using another version because also we are using Replit. So if you haven't created any account on Replit, I suggest to you to do this right now. It's pretty easy. You only have to go to the page. You can use Google or GitHub or maybe your email account and just accept the default configuration, and that's it. Okay, well, now let's go to Replit and let's create a Replit. It's pretty simple. You have to click right here and create REPL. We use the template Python, and let's use the random title that is given to us by the platform, so you will get. If you haven't seen Replit before, remember that in our first video of this series, um, we have explained how to create a account, what is Replit, etc. Okay, so by now you have to have some knowledge about this. And let's take this informal introduction to Python. Okay, remember the idea is to follow the tutorial, but it's not to just to read the tutorial. Okay, so I'll be commenting the code, explaining what is this code, using my own example if possible. So don't worry, we don't go reading line by line. Okay, it would be boring to do so. Okay, so let me explain something about this editor. Okay, that is present here. As you can see, there is a main.py file. If you have Python in your own machine, you can name the file that you want to run as you want. Maybe instead main.py, you can say script.py, index.py. I don't know, whatever you want. But in this case, because of the platform configuration, the file that you want to run should be named main. Okay. If you change the name, you have also to change all the configuration, and that's a nightmare. So let's do this in this way. Just use main.py to avoid any confusion using this platform. Okay. Now, as you can see, you have this editor, this button run, and this console. We explained in the previous lesson what is the philosophy, the paradigm behind Replit. That is just the REPL, the read, eval, print loop. Okay. So in this case, we will just use that. Okay. So let me explain this comment that is right here. Okay. Uh, Many times we want to create a program and we have to use something called variables. Okay, so you can see variable right here. So what is a variable? Let me explain in this way. For me, a variable is you can think a variable is just a pair. Okay, a pair of a name and a value. Okay, so If you have something like in mathematics, let's say x equals to 1, okay, something like it. Well, in programming, it means that you have assigned this value, okay, to this name. So it's attached to the name x, okay. X has a value of 1, let's say it that way, okay. So let me explain this, but now using comments, okay. This is important because sometimes we need some text inside our code to explain to another person what is going on, okay. So if we try to use just text without this hashtag, it will be an error. For example, I want to explain you that a variable is a pair of name and value. Okay, I want to write this to for a better understanding, but if I try to run this, I will get an error because Python will try to read this line that is just an explanation as a piece of code, a line of code. So it doesn't make sense for Python to say a variable is a pair of name and value. So we can just put an hashtag just before my explanation, and this is what is called a comment. Okay, it's just that. Now, how can we assign this value to the name? Well, we use this syntax. Okay, name equals value. In this context, equals means as an assignment. Okay, not a mathematical equation. Be careful in this case, okay? So in this case, we have assigned this, and for example, we can just print x plus 1. As you can see, you will get 2, okay? Because the value of x is just 1. If you change this value, and let's say we use 1.5, it's just 2.5, okay? That's it. So that's it for variables, and also pretty important. Each variable should have a type. Okay. For example, let me introduce you to the type. Let me write this. So with this function that you could see here, by the way, let me check if I can't use another theme. If you want to change your theme, you can go to the left sidebar. Let's go to user settings, and you can choose another theme. For example, I use dark rainbow. No, I don't want to create a theme. No, please. I just want to use a already created theme. Explore themes. Okay, let change this just for a moment. I think that is too dark, and for me there is not enough contrast. Those are pretty popular themes, yes, you can see. But I think that we need something else because it's too much, it's too dark. There is not enough contrast. For example, we can go for VS Code Dark or Python Dark theme. Let's use this just for a moment. Okay, use this theme. No, I think now the now the now the comments are pretty dark. Oh man, let me change this one. I want to use another theme maybe. Oh, okay. If somebody else want to say I can I think that this is much better. Okay. Okay, let me go to home. Let me open our last REPL and close these user settings. Okay, much better. The comments are now in bright color, but I think it's okay. The variables are more visible. Okay, so in this way, if you have x equals to 1.5 and you print the type of x, not x but the type, you would see which type of number is this. Okay, for example, in this case we have 1.5. So if we see something like float, class float, in another lesson we will explain what is a class. This is just a decimal number. Okay, now for example, what if x equals to 1? You will see int. So what is int in this context is an integer. Okay, let's use a string. Okay, remember the string should be wrapping by quoting marks. Now I remember the name, quoting marks. So in this case you will see the string class. Okay, in this case str is a string of characters. Okay, there are other another classes. For example, we will see very soon this kind of classes, something called lists, and in a list we can put anything we want. Okay, so in this case, well, it's not necessary to put this, it's just a list. Okay, nothing else. But also there are another special values that called booleans. Okay, so if you take a bool, in this case is bool is a boolean. Sorry, but that and true and false are the only two boolean values. So those are special values related with mostly with some propositions in the sense of mathematical logic. So those are special characters. Okay, so you can see well, there are a lot of another kind of objects. For example, you can have something like something called strings, sorry, dictionaries, and many else. But well, let's take our time one by one just to not get confused. And just I want to show you something that is pretty important. It's related with the floats and the integers. For example, if you use 1.0, most of the time you could think, well, it's just dot zero is 1.0 is an integer because it's just the number 1. But in Python, if you use the decimal point, you get a float. Okay, so this is important because in another languages you can use something like this, and using something like this you are telling the machine that x should be an integer, and you can initialize this something like this. And if you try to do something like this, maybe you get an error, or maybe you have a coercion. The machine casts the number to an integer in some way, anything else. Okay, but in Python that's not the case. Okay, Python tries to infer the type of the value. Okay, for simple values, it's pretty easy to convert those ones, but we'll see that sometimes, for example, in data science, when you import something from a Excel file, for example, when Python tries to infer the type of value, maybe he's not. It is not a good idea to let Python to do that. Okay, so that's it. And well, this is about this first example. Okay, fine. Well, now we have this thing about the different types, but for now let me introduce you just for to some arithmetic operation that I think that are pretty important. And as you can see, well, the basic operations are pretty simple. For example, you can just multiply numbers, for example, an integer. By the way, let me close right here the console. Not close, but clear the history. If you multiply integers, you get an integer. Okay, so this is it. Indeed, if you print this value, let me create a variable that is output for any some operation. Okay, let me print the output and also the type of the output. By the way, you can see that in this platform you can use this AI, but well, sometimes it's quite annoying to use this AI because the competition are not the best. But well, we will use this. Try to to avoid typing too much. Okay. For example, another thing when you say this like this little red worm is because there are some error, and it's useful because before running anything else you can check what is the error. In this case it says output is not defined because it should be output with another thing. Let me run this, and as you can see the output is 6, but as an instant of the class integer. But for example, what if I multiply, let's say, an integer by a decimal? So the output, as you can see, is a float number. Okay, even if this number 7.0 could be interpreted as an integer. Okay, so be careful with that. Be careful with that because here we have some kind of question. You can operate different expressions, but you have to be careful. Okay, and of course, if you use two float numbers, of course the output will be a float. Okay. This is pretty good. I think that this is a good idea. A good error, a good from the machine, because it will be give us a good example of why it's important to be careful with the floating numbers. As you can see, if you perform this in a regular calculator, you will get 7.7. Okay, exactly 7.7. But as you can see, we have quite a strange chain of zeros, and at the end we have a number 1. Okay, that's not correct. Well, the problem is the way that the machine stores the floating numbers. It's not the same as the integers, and the machine use some tricks to store this kind of numbers, because those numbers need some precision. But when trying to save these kind of numbers, sometimes there are some errors related with the way that the machine stores the floating numbers. So be careful, because as you see right here, the output right here is pretty different from what we expected. Well, but a very tiny number, but it's not an exact answer. Okay. So that's the problem with the float numbers. By the way, there is another kind of way to store these decimals, like using fraction. I think that if you want to use fraction, you can look for this in your browser. There is a special the special class called the fractions. Okay, and you can use this library. We will see in another lesson. But well, if you want to use fractions, for example, you can import this library, and you can for example store this like a fraction. Okay, and you will get this pretty extreme number. Indeed, I think that it's better to wrap this like this. Let me run again. Okay, I guess that it's better. Be careful, because as you can see, the constructors are not the same. If we use dot point dot sorry 2 dot 2 and 3.5. The answer could be pretty strange, so be careful. So as fractions, it just is like this, and well, indeed you can print the output as a float. You can convert this output like as a float using this function that is called float, of course. Okay, and well, that's the exact value. Okay, but I guess that for most of the application, it's too much to use fractions. Well, even some real numbers are not fractions, so fractions have some limitations. Okay, so let me return to this idea, and just be careful with the floating numbers. Okay, so that's it. But also you can interact. You have something else like multiplying integers by a string. This is possible in Python, and this is just like having uh, it's like concatenating the string twice. For example, if you do this 3 times, you get ABC 3 times concatenated, and you get a string. Okay, so there are many operations that you can perform between two different between two variables with different classes. Okay, from different classes. Okay, that's important to know. Well, that's it. Now we play a little bit with multiplications, and for now, just let me stick to the numbers, integers or floating decimal numbers. Okay, and there are many operations that we could do, like this one. Of course, this is 6. You can add decimals to integers, as in multiplication you get this float, etc. For example, you can do this. Let's do this, but with a subtraction. Of course, 0.5. Okay, so for addition, multiplication, and subtraction is just as you know, the usual operations. Okay, but there is something in Python that you have to be aware about. Okay, and this is a thing with the divisions. Okay, so for example, what if we want to divide 7 over 2? Okay, of course we have two integers, and in some languages, if you have two integers and you divide those integers, if the quotient is not exact, sorry, the division is not exact, that's it, the remainder is not 0. Some languages converts this number that is at first a decimal to an integer by rounding. Most of the time, just truncating the number. Okay, but that's not the case in Python, so you have to be aware. If you divide these two numbers, you get a float. Okay, Python understands that this is not won't be an integer, so it just convert the number to a float. Okay, that's it. Well, but what about of course, if you have another pair of decimals, the division will be a floating number, a decimal divided by an integer, also floating number, an integer divided by a decimal, of course it will be a float. And well, even if you do something like this, you will get a floating number, because remember, for Python this is a float. Okay, a decimal number. Okay, but what about if we have something like this? Let's say that we have 8 over 4, and you can say, well, that will be an integer, right? Because if you take 8 over 4, of course it's 2, and it is an exact division. But as you can see, Python convert this to a decimal number. Okay. This is important because sometimes you want to perform some operation grouping elements in subsets, and you want to iterate over a range. And it's important to be aware of this. It's very common because if you try to use this output variable for example, for an iteration using the range function, okay, it won't be possible. Okay, so just let me explain this in one moment with an example. We have something called the range operation. Let me run this example right here. Okay. Okay. When I run this code, you see something like this at the bottom. You can just unpack the values using this star operation. Okay, and you can see the range is just 0, 1, 2, 3, 4. Okay, the 5 is not included. That's the Python convention. We will talk about this later in another lesson. But you have to be aware because, well, you can see, well, it's okay. We have a 5 over 5, and we get the first 5 natural numbers. Okay, pretty lovely. But if we try to do something like this, let's say we have 20 over 4, that of course is 5 again. As you can see, you will get an error. Okay, even if this number should be an integer, Python interprets this like a floating number, and this number is not allowed for a range function. Okay, well, but well, we can see that this is not a good feature, but fortunately Python has a integer division. Okay, it's pretty useful and pretty easy to use. That is double slash. Okay, and if you use the double slash, just let me comment this for a moment and clean the console. Okay, that's it. Well, the double slash is just to converts this division to an integer. Okay, so it avoids the floating case. Let's see what happens if the division is not exact. Even that, the number is converted to a 2. Okay, you just take the integer part when there are rules for negative numbers, but let's stick to positive ones. For positive ones, if you have this, it just get the integer part and gives you this output. It could be also named as a quotient. Indeed, is a quotient. Okay, that's the right name for this, and the quotient of 9 over 4 is just 2. But maybe you remind that there is something else called the remainder. And the remainder is, well, if we know that when we do the division, it just 9 over 4. Well, we can form two sets of length, well, of size 4. 2 times 4 equals to 8, and it will be another unit that is alone. Okay, so that's called the remainder, and you can of course print the remainder, and also you can print the type of remainder, and in this case both numbers will be integers. Okay, so that's it. So what is the interpretation of the remainder? Well, the idea is that you have this number. Let me call this pretty quickly. Let me call this n. That is for number, and d for divisor. Divisor. I don't remember what is the right name. So if you have the quotient multiplying the divisor plus the remainder, it should be equal to the original number. So if we print this operation, Okay, we get 9. Okay, so that's the idea with this integer division. And for example, that is pretty important. If we want to have some range running for run from 0 to the last subset, we can use just the double slash, and everything will work perfectly fine. Okay, that's the idea. That's what is important to remind about this operation. Okay. Well, and that's it for the most common operations. Okay, just one more, and it's the power. Okay. For example, if you have a number called the base, let me call this the base, and the exponent, you can just have the exponentiation by using the double start. Okay. Let me take the base at the power of the exponent, and this case is 2 at the power of 3 should be 8. Okay, just this last operation. Okay, and that's it. For example, you can have, of course, we can try with a decimal base. It's perfectly fine for Python. Let me take this one and now use a fraction. Okay, let's try. And it makes sense because if you use a half like an exponent, it's like taking the square root, and the square root of 4, of course, is f2. Okay, and as you can see in this case, when the base is a decimal with the exponent is a decimal, we got decimals. Okay, so we have to be aware because this operation sometimes is an integer like here, and sometimes it's a decimal. So please be careful, and of course with the operations. One more thing about this is that you can use this operation. For example, in many calculators you can find this wedge represents the exponentiation, but in this case you will be for Python it doesn't make sense. Okay, but there is some case. For example, if I use 1 and 1, let me use this. Of course, 1 at the power of 1 is just 1, but if we try this one, we get 0. Why? What is that? Because indeed, for Python, this wedge is not exponentiation, it's the XOR operation. Okay, that's another thing. Maybe in a course of mathematical logic we can talk about XOR operations, but for now be aware that this operation is not exponentiation in Python. Okay, if we change this, well, it's like expected, but at the power of 1 it's just 1. Okay, and well, that's it. There are another examples right here in Python. I think that one of these that are pretty important is this about the taxes. Okay, if you make some taxes, well, if you have some price, well, here in Mexico, most of the time the price includes the tax, and the price that you see in the tag is includes the tax. Okay, but for example in the US, I think it's not the case. You have to add some tax. So in this case, should be the tax rate. And for example, you can take the tax as the price times the tax rate. Okay, and the final price, for example, will be the price plus the tax. Okay, and this is it. If we run this one, we have the final the final price. Okay, and that's it. For example, in this case, it would be useful to have some program to doing this. For example, because you can just change the price, and you just run again your code, and you get the final price. But well, there is another way to do this. There is a better way to do this using functions, for example. Well, we will see that in another opportunity. Okay. Just for now, we have covered the first section of using Python as a calculator, and we have covered the numbers. Okay. So tomorrow, no, sorry, not tomorrow, but on Friday, we will see a little bit more about text, how to process text using Python. Okay, and that's it. Well, I appreciate that you have been here in the live session, and if you don't have the opportunity to watch this session on live, you can see also my YouTube channel that is in the description of the channel, and you can see the recorded sessions. Okay. Well, thank you a lot for being here, and well, see you on Friday. Bye bye.